Hello, everyone. My name is Arman, and we're going to study Math 230, Introduction to Ordinary Differential Equation this semester. Differential equations basically appear in many fields, whether you study biology or social sciences or physics or mathematics. Basically, differential equation is an equation, first of all, as you can guess from the name. It's an equation that relates derivatives of a function with the function itself. And the goal is to find such a function. So algebraic equations, you saw algebraic equations in high school and middle school. So for example, they could relate, let's say, powers of a variable x. Or if x is a number, for example, then in an algebraic equation, you have a relation between powers of x and x itself, right? For example, let's say x to power 2 equals x. And the goal is to find such a number x. Well, here also in differential equations, instead of dealing with numbers, we deal with functions. So that's one difference. So instead of x, we usually use y to denote or emphasize that we are dealing with a function. And let's say we have a relation between derivative of a function and the function itself. So let's say, for example, we could have y prime equals y. Well, y prime denotes derivative of y, right? So let's say if a simple example of a differential equation, let's say y prime equals y. This is an equation because there is an equality sign and there is a relation between derivative of a function y and the function y itself. So we know that y prime equals y, and our goal is to find such a function whose derivative is equal to the function itself. Well, in this simple example, let's say y prime equals y, you probably saw that in Math 113, that if you consider exponential function e to the x, y equals e to the x is a function whose derivative is equal to the function itself. So one solution of the differential equation I just mentioned, y prime equals y, is y equals e to the x, because when you consider y equals e to the x, the derivative of e to the x, or y prime, is same as y itself. So that's just one solution of this differential equation. But of course, our goal is always to find all solutions of a given differential equation. So we need to learn about a systematic way to find all solutions of a given differential equation. So for example, what are all solutions of y prime equals y? Now, if I modify my equation, let's say y prime equals 2y, for example, if I'm looking for all functions y whose derivatives are equal to 2 times the original function, what will be the solutions? Or we could consider more and more complicated differential equations. For example, y double prime plus y prime equals, for example, y. What are the solutions of this type of equations? So we can consider many different types of equations, and for each type, we need to learn a systematic way or an algorithm to find all solutions of a given differential equation. So what I was saying was that, these differential equations appear everywhere because, in Math 113, you learned that derivative of a function represents rate of change of that function. So let's say, for example, in biology, if you want to consider a number of bacteria, for example, as your function, and you know that rate of change of bacteria is proportional to the number of bacteria. So that means y prime is equal to some constant times y, right? Because rate of change means derivative. And if it's proportional to the function itself, that means y prime is equal to some constant k times y. And then you want to know what will be the solution. Or in social sciences, for example, y could be population of people as well. Or in biology, doesn't have to be number of bacteria, it could be population of people in some specific place or worldwide. Or in physics, we know that rate of change of position represents velocity, and second derivative for position is acceleration, right? So we can set up differential equations that way in physics as well, because we can find out about the connection between derivatives of a function and the function itself. For example, in physics, you know that if you have a spring, F is equal to Kx, and F is ma, and a means second derivative of x, right? So this is already a differential equation, that m times second derivative of x is equal to k times x itself. So it's an equation, it relates, it gives a connection between derivatives of a function, in that case x. Well, x in that case is a function because it's a function of time. In mathematics, x usually denotes independent variable, and dependent variable is usually denoted with y, which is a function of x. But in physics, usually t denotes the independent variable and x denotes the dependent variable, which is a function of t. So in physics, when we say x, it's a function itself. So when you say m times second derivative of x is equal to k times x, that is a differential equation because it relates derivatives of the function, in that case x, with the function itself. And our goal would be finding all solutions, all functions x satisfying this property. So we'll see some examples of differential equations in this course, some applications, but my point is differential equations are everywhere in all different fields. And this course is just an introduction to learn about some basic differential equations and solving some basic differential equations. But this is still an active, basically, field of research that still researchers around the world, mathematicians around the world are still trying to find, come up with ways to solve specific, of course, complicated types of differential equations. So we'll have two types of differential equations. I will explain that shortly for you. But first, let me go over the course outline, what we want to do during this semester. So let me share my screen here. Okay, here's some basic information about the course. So I'm sure you know about most of them. So the office hours will be with Zoom. I wrote the meeting ID and passcode for that. And then for the textbook, please note that the text will be open source and you can easily download the textbook with this link that I included here. And I also wrote some learning outcomes for this course, you know, what we want to do. I briefly said so far, but let me explain a little bit more. So basically, if you want to look at the course, we can divide this into a few parts. So first, we'll look at the first order differential equations. So first order means like the highest derivative that is appeared in our equation is the first derivative. Remember, we said that differential equation means an equation that relates derivatives of a function with the function itself. Now, if the highest derivative or the highest derivative appeared is the first derivative, then that's called first order differential equation. So first we will learn about first order differential equation and how we can solve them and some applications, of course. And then we will look at higher order differential equations, for example, second order, mostly second order differential equations. We will also take a look at some simple examples of higher third or fourth or higher order differential equations as well. So again, second order means, the highest derivative appeared in your differential equation is the second derivative. Third order differential equation means the highest derivative appeared in your differential equation is third derivative. So for example, if I say y double prime equals y double prime equals y is a differential equation, which is second order, because the highest derivative appeared is second derivative. Then we'll look at some systems of ODEs. Systems of differential equations. So similar to, if you want to again compare it with algebraic equations in middle school, first you learn about a single algebraic equation, how we can solve a single algebraic equation. Let's say one variable or one unknown and one equation. Then you looked at a case where, let's say you have two equations with two unknowns. How can you solve two equations with two unknowns simultaneously? So you have two unknowns, let's say x and y, and two equations, for example, 2x plus y equals 5, and let's say 5 y minus 2x, for example, equals 6, and then you want to find x and y. So again, similar concept can happen in differential equation. We can have two differential equations at the same that we want to solve simultaneously at the same time. So let's say we have two functions, for example, let's say y and z, and we have one equation. We have two differential equations, for example, y prime plus z prime equals something, and 2y prime minus z prime equals some other function, for example. Two equations with two unknown functions this time, and we want to solve them simultaneously. So this is the place where we will use some linear algebra techniques. If you look at the prerequisite in the course outline, the beginning of the course outline, you saw that we mentioned about Math 252 as a prerequisite. Math 252 means linear algebra. So in this chapter of systems of differential equations, we need techniques from linear algebra because, remember I told you, for example, we could have y prime plus z prime equals something, 2y prime minus z prime equals some other function. So one way to solve this and to analyze this type of a system, first we can write it as in the matrix form. And writing equations in matrix forms, is something that you learned in Math 252. Of course, in Math 252, your unknowns were numbers. For example, x and y were numbers, but here are functions. But the concept is still the same. The techniques are still the same. So we can, for example, write systems of ODE, a system of ODEs in a matrix form, and then we can look at, for example, we can see whether that matrix is invertible or not. That's also important, similar to the situation that you were dealing with in linear algebra. And then, for example, eigenvalues of those matrices were important as well to analyze the system. For example, if you want to diagonalize the matrix, if you want to diagonalize the matrix, you could look at the eigenvalues and eigenvectors. So same thing here. To solve the differential equations, we can write in the matrix form, then we can look at eigenvalues of those matrices. And then I will explain how we can use eigenvalues to solve those systems and find the solutions. So the concepts and techniques in linear algebra is required in this chapter because we are still dealing with systems of equations, but the only difference is that in Math 252, your unknowns were some numbers. Here, the unknowns are functions, unknown functions. And then we'll look at Laplace transforms. Laplace transforming is a technique for solving differential equations. So we learned different techniques for solving different specific or different differential equations. One common technique is using Laplace transforms. Why is this important, using Laplace transform? Basically, if you want to describe it in a simple sentence, simple wording, is that Laplace transform is a method that converts a given differential equation to an algebraic equation. Well, in middle school and high school, you learned how to solve algebraic equations. Like, for example, like I said, x squared plus x equals some number, for example, where x is a number, not a function. So when we transform a given differential equation using Laplace transform, we will convert it to an equation where no derivative will be appeared there. Because the difficulty in solving a differential equation is because of derivatives. Because derivatives appear, they become complicated to solve. Like I said, still mathematicians are still trying to solve some specific differential equations which are not solved yet. But when you convert it to an algebraic equation, all derivatives will disappear. And once the derivatives are disappeared, then we have an algebraic equation, and we can solve that algebraic equation like very easily, like what you learned in high school. And we will find a solution for a specific algebraic equation. Then we can convert it back to a differential equation, convert it back to a function. So I'll explain about all the details later, but the idea is that we have a differential equation, we switch to an algebraic equation, we'll find a solution for a specific type of function, which is related to the original function that we want to find, and then we convert it back to the original function that we were looking for, which was supposed to be a solution for our differential equation. Okay, I'll explain about all the details later. And the last topic we want to cover in this course is power series method. Well, power series is a concept that you learn in Math 114 in Calculus 2. You know that most functions have a power series form. So when you write a function in a power series form, then it's easy to deal with it. Well, first of all, power series, if you remember, it means that, it's a generalization of a polynomial. Polynomial contain a finite number of terms, right? X to some highest power, which is called degree of polynomial, plus lower powers of x, all the way plus a constant. But if we generalize this to an infinite sum, like for example, a0 as our constant plus a1x plus a2x squared plus a3x cubed plus ... Then if we have an infinite sum of this form, then we'll call it a power series. Now, most functions, most common and known functions are, most common functions, basically standard functions like exponential functions, trigonometric functions, polynomials, of course, and logarithmic functions. So these functions, each of them has a power series form. When you write a function in a power series form in Math 114, you learn that it's easy to deal with it. For example, if you want to integrate, well, you know that integrals can become very hard, right? Even for seemingly simple functions. But when you write something in a power series form, then you can easily integrate, because you can easily integrate polynomials. You know that integral of For example, x to power n is x to power n plus 1 over n plus 1, right? So we can easily integrate, just integrate term by term, and then you can find the integral of that function. So similar thing happens here in differential equation. When we have a differential equation and we want to solve it, if we write the function that we are looking for, that's, I usually say in mathematics, we usually call it y, the function that we are looking for. Let's say if we write it in a power series form, if we write it as sigma a n x to power n, and then plug it back to our differential equation, we will find a recursive relation that can help us to find the coefficients a n. A recursive relation means a relation that expresses one term or one term of a sequence in terms of the previous terms. For example, if I say an plus 1 is equal to, for example, 5 times an. That's a recursive relation because, you know, it gives a2 in terms of a1. So if you have a1, then you can find a2 in terms of a1. And then you can find a3 in terms of a2, and a2 itself was written in terms of a1, so a3 can be written in terms of a1. a4 can be written in terms of a3, which itself can be written in terms of a1, so a4 can be written in terms of a1 as well. So if I have, for example, an plus 1 equals something times an, once I have, for example, a1, then I can find all their next AIs, for example, A2, A3, A4, A5, all of them, I can find them in terms of A1. Or if the index starts from 0, once I have A0, then I can find A1, A2, A3, A4, A5, all of them in terms of A0. Okay, so power series method is a method whose concept you learn in Math 114. Again, we can assume, in most cases, we can assume that the function that we are looking for has a power series form, and then substitute it back into our differential equation and just find the coefficients, A0, A1, A2, A3, etc. Okay, so these are the topics that we want to cover in this course. Very briefly, the chapters that we want to cover. And then I also wrote about the evaluation methods, basically about the tests that we are going to have and the homework. So we'll have 3 tests. I wrote the dates of tests for you: Thursday, February 3, February 24, and March 17. All of them 8:30 p.m. to 10:30 p.m. Okay, so at nighttime, the times are all at nighttime. The reason is that, well, in the morning, I suppose that you probably have some classes. So in order to avoid conflict with those, so I considered 8:30 p.m. to 10:30 p.m. as our exam time. And also I wrote the dates. So I assume that you're okay with the dates and times. If not, you have to let me know by Thursday, January 13. You have to let me know that which date or time you're not okay with it, and let me know about the reason as well why you're not okay with it. Okay, so please try to accommodate as much as you can to so that we can fix these dates and times for our tests. But if there is something that, you know, there's absolutely no way that you can accommodate, then you have to let me know by Thursday, January 13, and that, you know, which date and time does not work for you. So each of these 3 tests worth 17% of the final 100%. So that will be 51%. 7% will be online homework. I will explain about that shortly. That'll be 58% and 42% final exam. That adds up to 100%. So what is online homework? Well, we will have the homeworks will be assigned, the online homework will be assigned with this website called WebWork. So I included a link here. You can click on it, and basically your username and password are both your student ID. And then after you log in, then you can change your password, of course. And I recommend that you change your password after you log in. But your default username and password are your student ID. The username will stay the same. It will still will be your student ID, but after you log in, please change your password. So each week I will assign some homework there, and let's say overall could be, for example, 350, for example, marks total. So that will be end of the semester. I will look at your grade, and then I'll find the percentage, but the weight of this part of the course is 7% out of 100%. So if you do all the homework perfectly, that means you will have 7% of the 100% of the total grades. And if not, it will be, the ratio will be counted. Okay, so I also wrote that for this is a flex course, so I will upload the lectures basically on YouTube, on my YouTube channel, and basically, but I will include the link on Moodle. I will include the link on Moodle, and 2 lectures each week, and one by end of the day on Wednesday, but one by end of the day on Saturday. And there's only one exception: in the weeks that you have tests, there will be only one lecture uploaded, because one test basically will be counted as our second class in those weeks. But except those 3 weeks that you have midterms, and those 3 weeks, there will be only one lecture uploaded, and the other weeks you will have 2 lectures uploaded each week. And about the tests, I explained a little here. Here you have to go over the instructions very carefully. The tests will be closed book. So the way that it works is that, in the beginning of each test, I will read the questions out loud for you. So of course the test will be also with Zoom meetings, and it will be online. But in the beginning of each test, I will read the questions out loud for you. During that time, you're allowed to look at the screen to make sure that you copy the questions correctly. And that can take around, let's say, 20 minutes, for example. After that 20 minutes, then you are not allowed to look at the screen anymore. So after 20 minutes that you wrote all the questions on a piece of paper, you copied the question on a piece of paper, then you have to look at your own paper only, your question sheet, for example, and write your solutions based on the questions that you wrote on a piece of paper. And during the next 1.5 hours, you will not be allowed to look at the screen anymore, or talk to anyone, or talk to yourself. And you will be only allowed to look at your own paper and your solutions. You have to come up with your solutions that way, and you're not allowed to look at any electronic device, any computer, any cell phone. Okay, it's a closed book. Or you're not allowed to use any notes, nothing. Just look at the own paper and the questions that you have already copied. Okay, so that part can take around 1.5 hours. During this 1.5 hours, like I said, you have to only focus on your solutions and look at your own paper. And after that 1.5 hours, then I'll give you an additional 10 minutes to scan your exam and upload it on Moodle. So you can scan your exam. The way that you have to scan your exam is that you take pictures of your papers and your solutions, and then you have to use an application like Cam Scanner in order to convert those pictures into one PDF file. It's very important that the file that you want to submit is just one PDF file, not multiple pages or not multiple JPEGs or multiple PDFs, just one PDF file that you have to submit on Moodle. Okay, during those last 10 minutes that you can upload your scanning and uploading your exam, again, you can use your phone to take pictures and then convert it to one PDF file. So again, if I want to summarize, I can say that each exam consists of 3 parts. The first and last part, you're allowed to look at the screen or use your phone, because in the first part, you want to copy the questions, you want to look at the screen to make sure that you're copying correctly. Last part, you're scanning your exam. Again, you can use your phone. But the main part of the exam is the like 1.5 hours in the middle, like that I said. And in that part, you're not allowed to look at any screen, any book, any notebook, or talk to anyone or talk to yourself. And also in the beginning of the exam, it's very important that you set up your webcam according to the instructions, so that I can monitor. It's a basic proctored exam, and I can monitor everyone through webcam. And so the way that you have to set up your webcam is that your face, hands, and papers must be visible as well as your surroundings. So surroundings must be also visible, and also the surface in front of you. For example, if you're sitting on a floor, you're allowed to sit on a floor, but then the surface of the floor must be visible. If you're sitting next to a desk, surface of the desk must be visible. If you're sitting on a bed, surface of the bed must be visible. The surface where you're putting your papers there, that must be visible. It's very important. So if any of these instructions are not followed, then unfortunately I have to fill the cheating report for those students. And also one important thing is that checking webcams is just one way that I use in order to ensure integrity of the tests. But I also make sure about integrity of tests based on the papers that are submitted. So it happened in the previous semesters that some students were charged with cheating or plagiarism only based on their papers. And then they told me, okay, during the exam, you didn't tell us anything or charge us. And then I told them that, well, that's just one part, the checking webcam is just one part or one way that I use for ensuring the integrity of the test. I also have other ways and other tools that I can find out about any possible cheating or plagiarism based on the paper. Only based on the paper I can, and there are many ways that I use to find out about possible cheating or possible plagiarism. Okay, so I know that well, most students are honest, and they follow the instructions very carefully, but I have to do all these in order to make sure that all the tests and everything is fair for those honest students, which consists of almost most students. Okay. So here also, please go over these instructions very carefully. For example, I wrote that about the surrounding and what I mean by the surrounding being visible. So for example, I remember I told you that the surface in front of you must be visible. All the papers must be there. So the surface, basically the papers must be in the middle of the area that are visible, not in the border. Because if it's in the border, if let's say some other person adds some paper there, then I cannot see it, right? So all the papers must be quite in the middle of the area which are visible, so that I can be sure that no papers are added or anything during the test. Okay, so I told you about the homework as well. That online homework, we have online homework with the web work, and then that will be 7% of the total grade. But in addition to that, we'll have some additional assignments, because online homework is based mostly computational questions. So I will include some more computational questions as well as some conceptual questions in additional assignments. And additional assignments, I will upload them on Moodle. So you don't have to hand in additional assignments. You can just practice and try to complete them for your own in order to get prepared for the tests. Okay, you don't have to hand in them. There will be no weight assigned for them. Just make sure you complete all those additional assignments in order to get prepared for the test, because many questions in the tests are similar to those questions. Basically, most questions in the test are either similar to the additional questions or web work questions or lecture notes. So these are three main resources that you can use to get prepared for the test. First of all, lecture notes, and then additional assignments, and then web work questions. Okay, so if you miss an exam, 0 will be assigned for that exam, unless you provide a doctor note for that during the next week, the week after you miss the test. In that case, you should also inform me before the test. Inform me before the test that you cannot attend the test due to an illness, and then you have to submit the doctor's note the week after. All right, so let's get started. So I'm going to do math 230, ordinary differential equations, or ODEs. I'll explain shortly what we mean by ODE. So first of all, let me remind one more time what we mean by a differential equation. A differential equation or abbreviated by DE, is an equation that relates derivatives of a function with the function itself. So this is the most important sentence we have said so far. If you have an equation, one side equals another side, and you have a function y involved and the derivatives, the function y and the derivatives are all appeared in your equation, then you will call that a differential equation. And what is the goal in a differential equation? The goal is to find the function, the unknown function. So the goal is to find the unknown function. Okay. Now we have two types of differential equations. Two types of differential equations. First type, ordinary differential equations. Or ODEs. So in this case, we have a function of one variable, say y equals y of x. So if you have one independent variable and one dependent variable, so let's call the independent variable x and the dependent variable y. So this is normally the notation we use in mathematics. In physics, like I said a few minutes ago, so this is in math notation, math standard notation. Or x equals x of t. This is physics standard notation. In physics, we have one, again, if we have one independent variable, we normally call it t, representing the time. And one dependent variable, if let's say if it's the position, then we can call it x. So x in physics is the dependent variable, is the function, t is the variable, but in math notation, usually x independent variable, y is the function, y is the dependent variable. So any of these two notations can appear in this course. Okay, so we could talk about y as a function of x, or we could talk about x as a function of t. So, and what is the general form of a differential equation? And let's say with y equals y of x notation, and ODE can be written in the following form. The general form of an ODE, let's stick with the mathematical notation for now. An arbitrary ODE can be written in the form of f of x and y prime, and all the way to y nth derivative equals 0. So you can have a mixture of x and y prime, y double prime, all the way to nth derivative. This n could be any positive integer. If it's 1, for example, it would mean y prime. If it's 2, it would mean y double prime, right? So we are allowed to have any derivative of any order appeared in our ODE. So for example, let's say y prime equals x plus 1. This is an ODE. Why? Because it can be written as a y prime minus x minus 1 equals 0. So this is basically my f of x and y prime here. I remember I told you that any ODE can be written of this form. Now, if this is your ODE, y prime equals x plus 1, then that means your function is a function of x and y prime and can be written as y prime minus x minus 1. So see, I wrote 0 in the right-hand side. I wrote 0. So it's no big deal. If the right-hand side is not 0, you can take everything to one side and you can still write it as some expression equals 0. Okay, or another example, let's say y prime equals y plus 3x plus y prime x squared minus xy. This is also an ODE. Again, you can easily find out what f is. This f here. If you take everything to one side becomes 0, the other side becomes a function of, in this case, x and y prime, right? So these are some examples of ODEs. Now, in ODE, there are a few important features. So one important feature is the order of ODE. So order of an ODE is defined as the highest order, highest derivative order appeared in that ODE. So in order to define the order of ODE, just look at the highest derivative highest derivative order appeared. So if it's, for example, first the highest order is the first derivative, then we would call first order. If the highest derivative appeared is second derivative, then we call it second order, and so on. So for example, if you have, let's say, y double prime equals xy minus y prime, so then this is a second order ODE, since the highest derivative appeared is y double prime. Highest derivative is second derivative, so it's second order ODE. Another important feature of ODE is whether that ODE is linear or non-linear. So linear versus non-linear ODEs. When do we say that an ODE is linear? Now, a linear ODE, or let me say an ODE is called linear if it is linear in y prime, y double prime, all the way to y nth derivative. So it has to be linear in y and all derivatives of y. So we are not allowed to have, for example, y squared or y prime squared, or we are not allowed to have root y prime, square root y prime, or we are not allowed to have sine y, cos y. So these things are not allowed. It has to be linear in y prime, y double prime, all the way to y nth derivative, but not necessarily linear in x. But not necessarily linear in x. So a linear ODE can be written in the following form. So let's say a0 of x plus a1 of x times y, a2 of x times y prime, all the way to, let's say, a n minus 1 of x, y nth derivative equals 0. And so a n plus 1 of x, y nth derivative. Right? Because if you look at if you compare the indices, so this one, for example, is the first derivative, but the index is 2. This one is the 0th derivative, index is 1. So this index is always one higher than the order of derivative here. So if the last term is the nth derivative, the index here will be one more than that, which would mean n plus one. Okay, so it has to be linear in y, linear in y prime, linear in y double prime, all the way to linear in nth derivative, where a0 of x, a1 of x, all the way to a n plus 1 of x are functions of x. And if an ODE is not of the form above, then it is called non-linear. It's called a non-linear ODE if it's not of this form. If it's of this form, it's linear ODE. Otherwise, it's non-linear ODE. For example, let's say x squared equals 3y plus y prime. So this is a linear ODE, right? Because it's linear in y and y prime. It's not linear in x because there is a power 2 of x appeared, but that's okay. A linear ODE, according to the definition, doesn't have to be linear in x. It has to be linear in y, y prime, and all derivatives of y. Y and all its derivatives are linear here. There's power 1 for y, power 1 for y prime. There's power 2 for x, but that's okay according to the definition of a linear ODE. So this is a linear ODE because it is. So let me call this equation star. It is of the form star above with a0 of x here is x squared. And if I take everything to one side, because see this one, I can also write it as x squared minus 3y minus y prime equals 0. So a0 of x is x squared, a1 of x is minus 3, and a2 of x equals minus 1, right? The coefficient of y is minus 3, coefficient of y prime is minus 1. And a0 of x, the term with no y in it, is x squared here. Okay, another example. And let's say x squared equals root y plus y prime. So this one, okay, it seems that, okay, x squared equals root y plus y prime. This is not linear in y. See, power of y here is 1/2. Root y means y to power 1/2. All the powers of y and y prime and the derivatives of y must be 1. Nothing else is allowed. So power of y is 1/2, so it's not linear in y. So that means it's non-linear ODE. Another example, let's say sine x equals cos y plus y third derivative. It's okay to have sine x. This sine x is not linear in x, but it doesn't have to be linear in x. But cos y means it's not linear in y. Cos y, it's not linear in y. So this is not linear in y, therefore, again, non-linear. nonlinear ODE. And another example, let's say e to power x equals y fifth derivative plus x squared y seventh derivative. Is this linear? This one is also linear. Linear ODE, because it is of the form star above with a0 of x equals e to the x, and a1 of x, there is no y term, so a1 of x is 0, a2 of x similarly 0, a3 of x 0, a4 of x 0, a5 of x 0, a6 of x is -1, because if I take this one to the other side, I want one side to be 0. Remember that this is a star form equation star. One side is 0, so I have to take everything to one side. Then this becomes minus y fifth derivative. What is the coefficient of y fifth derivative? Again, please remember, coefficient of y first derivative is a2. Coefficient of y second derivative is a3. And continuing this way, coefficient of y fifth derivative is a6. So a6 of x, that's why I said it's -1. Coefficient of y sixth derivative will be a7, which is 0 because there is no y sixth derivative appeared here. Coefficient of y seventh derivative is a8. That is going to be minus x squared, because again, remember, I'm taking everything to the other side. So this becomes minus x squared, y seventh derivative. So a8 of x is minus x squared. So this equation is linear, although we have some terms that are not linear in x, but it's okay to have nonlinear terms in x. But the terms in y and derivatives of y are all linear. See, for example, this is y. See, this is not power. This number here, when I write in the bracket, you learn in math 113, that's when I write in bracket, it denotes the order of derivative. This means fifth derivative, not power. But if I have y fifth derivative, let's say raised to power 5, then that will be nonlinear, because then the y fifth derivative will not have power 1 anymore. And it will be nonlinear in 1/5 derivative. Therefore, it will be nonlinear ODE. But as long as this number is inside bracket, it does not mean power. It means the order of derivative. And power must be 1. Order of derivative can be anything. But if it's y, fifth derivative means this fifth derivative of y is raised to power 1, because there is no power here. And therefore, it's linear in this term, similarly linear in this term, and overall is also linear. Okay, so you have to be careful about whether this number is inside bracket, therefore meaning order of derivative, or not in bracket, which would mean power in that case.